All right, for this reteach, we are going to look again at filling out function tables and graphing them, and then identifying independent and dependent variables. So when we are graphing functions from a function table, we have our equation here, y equals 4x. We have our input x is going to give us our output y. We get to choose the input values. We can choose any values. I always try to do smaller values to make it easy. I'm just going to do 0, 1, and 2. Maybe you do 1, 2, and 3. I know this is going to fit into the graph. Now we're going to multiply 4 times our input value of 0. 4 times 0 is 0. So our ordered pair is x is 0, y is 0. And I'm going to plot that right here. 0, 0. Next point, I'm plugging in 1. So 4 times our input of 1 is 4. That gives us an output of 4. So we put 1 in, multiply it by 4, we get 4. So our x value is 1, our y value is 4. So we've got the ordered pair 1, 4. So we're going to 1 on the x-axis, up to 4 on the y-axis. Last one we're going to do is 2. So I'm plugging in 2 for x. So 4 times the x value of 2 is 8. So our input, our x value is 2. Our output, our y value is 8. We're going to plot the ordered pair, 2, 8. So our x is 2. Our y is 8. And then I'm going to connect these in a line. I'm going to draw an arrow on both ends to show that it continues on forever. If these didn't connect in a straight line, you must have plotted one of these wrong, because we're only looking at linear equations. Let's try another one. This time, we don't just have something multiplied by x, but we are adding a constant as well. So y equals 6x plus 4. I'm going to plug in the same values. I know that's going to be the easiest to fit on my graph. 0, 1, and 2. So we're going to plug into this function 6 times an x value of 0 plus 4. 6 times 0 is 0. 0 plus 4 is 4. So our output is 4. So we have an input, an x value of 0, and an output, a y value of 4. Next, we're plugging in 1. So 6 times our x value of 1 plus 4. 6 times 6 is 6. Plus 4 gives us 10. So an output of 10. So we have input x value of 1, output y value of 10. Oops, I forgot to graph these. So let's graph this. 0, 4. That means our x value is 0. We stay on here. We go up to 4 for our y value. And then 1, 10. Our x value is 1, up to a y value of 10. Last one, we're plugging in 2. So I'm going to do 6 times a y value of 2 plus 4. 6 times 2 is 12. Plus 4 is 16. So we have an output of 16. So we have our x value, our input of 2, our output, our y value of 16. So I'm going to where x is 2, up to where y is 16. And then I'm connecting, making sure these form a straight line, because if they don't, I did something wrong. Drawing an arrow on both ends to show that it continues on forever. Now let's look at independent versus dependent variables. Independent variables, it represents the x value, okay? It's independent of itself. It does not depend on another. The key type of thing that we're looking at for independent variables is time. Time is always independent. So that could be hours, minutes, months, days, nights, weeks, years, seconds. Anything that's talking about the passage of time is telling us that's the independent variable and representing x. Versus our dependent variable depends on that independent variable. It represents the y value. Two key things, not always, but two key things that represent dependent variables are money and totals. It would be great if money wasn't dependent on doing things or other things and we just had it, but that's not the case. So keywords that you might see are pay, spend, dollar, sell, buy, earn, or even just seeing the dollar sign. So let's look at picking out these independent and dependent variables. Number 3, the Field Museum costs $8 per person to visit. Write an equation to find the total cost for Emily and her friends to visit. So first thing I look at is there time in the problem? Do we see anything about hours, minutes, days, months, weeks, years? I do not, so I'm not finding that first. So I'm going to look for my other unit. Is there money or totals in the problem? Yes. I see the dollar sign. I see cost. So yes, there is. And we see total cost over here. So that's telling us that is our dependent variable. So the Field Museum costs $8 per person. So the total cost or the total amount spent would be our dependent variable. Well, what are we spending money on? It's the cost per person. So our other variable is going to be the number of people that are going. Okay, number 4. Katie is driving at a speed of 55 miles per hour. Write an equation to represent the total distance traveled. Is there time in the problem? Yes. I see the word hour. That is representing time. That immediately tells me that's my independent variable. So the number of hours is my independent variable. Now I'm looking at, do we see money or total? I don't see any money. I do see the word total. So yes, it's talking about total distance, or specifically the miles. The distance that we're talking about is miles. It's what per hour? Miles. So the number of miles is our other unit. Okay, number 5. Sheldon is building a comic book collection. He plans to get 10 comics per week, or 10 comics each week. Is there time in the problem? Yes. I see weeks. Weeks is talking about the passage of time. So yes, that is our independent variable. So the number of weeks is our independent variable. Now we look. Is there money or totals? I don't see anything talking about money. I don't see the word total. So no. So what are we talking about in this problem? What are we doing each week? We're getting comics. So the number of comics, you could say the number of comics collected. The total number of comics is our dependent variable. Last one, Target is selling sandals for $10 per pair. First, do we see anything about time in this problem? No. Do we see money or totals? Yes, I see that dollar sign. So yes, there's money. That tells us the dependent variable. So Target is selling it, and Target's trying to make money. So when I'm talking about the money, I'm not just going to say money. Target is selling to make money, so money earned, or total amount sold. So since we didn't have time, we got to figure out what the other variable is. It says $10 per pair. So our independent variable is the number of pairs, and if you want to be more specific, of sandals.